Okay, so we're going to continue our triangle congruence, and we're going to apply ASA, AAS, and HL to solve problems. And we're also going to prove that triangles are congruent by using these theorems. So first of all, an included side is the common side between two consecutive angles in a polygon. So for example, if I have this angle and this angle, the included side of these two angles would be this one right here. Okay? So first of all, ASA. ASA says that it stands for angle, side, angle, and it says if two angles and an included side of one triangle are congruent to two angles and an included side of another triangle, then the triangles are congruent. So for example, if I'm told that angle U and angle L are equal, and I'm also told that angle H and angle C are equal, so there's my two angles, and then I also need the included side. So that would be here and here. So if I'm given that information, then I know that triangle LHS is congruent to triangle UCD. Okay? The next one is right here we have if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the triangles are congruent. This is called AAS, which stands for angle, angle, side. So I have two angles again. So here I have this one, and then this one and this one. And let's name these. So ABC and DEF. Okay, so now I need a non-included side, and it does not matter which side I choose. I could either have BC or I could have AC. I'll go ahead and choose BC and EF are congruent. Therefore, triangle ABC is congruent to triangle DEF because of angle, angle, side. Okay, my next one is HL. And that stands for hypotenuse, leg. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent to each other. So here we have right triangles, and I'm told that the hypotenuse are congruent, and also one of the legs, and it doesn't matter which leg. So I'll go ahead and choose this one. And I can say, let's name these, EFG and HIJ. So I can say that triangle EFG is congruent to triangle HIJ because of hypotenuse leg, HL. Okay, so let's see if you can remember there are 5 ways to prove that triangles are congruent. We've learned all 5 ways in today's lesson and in the last lesson. Side, side, side. Side, angle, side, where we have 2 sides in the included angle. Angle, side, angle, where we have 2 angles in the included side. Angle, angle, side, 2 angles and a non-included side. And hypotenuse leg, if you have right triangles and you have a hypotenuse and a leg. Okay? So let's see if we can figure these out down here. Okay, see if you can figure them out. Go ahead and pause and look at them and see if you can figure out which one these 4 different pieces are. And then unpause and see if you got it right. Okay, go ahead and pause. All right, now we're back. Okay, so this one here, number 1, we have 2 angles. We also have a side that they share, so that's this one here. So this one would be angle, side, angle, since it's an included side. Angle, side, angle. Here we have 2 lines that are parallel. Whenever you're looking for whenever you're given parallel lines, always look for angles. There's angles somewhere in the picture. Parallel lines means angles, otherwise they wouldn't give it to you. So if we have these parallel lines, we have that the alternate interior angles are equal here. These are also alternate interior angles. And wait a second, we also have vertical angles. So this actually has way more information than we need because we've got a side and we know that all 3 angles are congruent. So we can either choose whether we want ASA, which would be these three, ASA, or we can choose angle, angle, side, which would be like angle, angle, side, or we can go this way, angle, angle, side. So you can either choose which one you want on that one. Okay, let's take a look at number 3. Here we have a triangle that's an isosceles triangle because we have two congruent sides here, and then we have an altitude coming down saying how tall it is because it's at a right angle. So these two triangles are right triangles. So they have the opposite sides, which are the hypotenuse. Those two are congruent. And then we also have a leg. It's right here. It shares the leg. So this one would be HL. Lastly, we have what looks like a parallelogram here with the diagonal put through. Opposite sides are congruent. We have this in the middle. They share, so that would be side, side, side. How did you do? Did you get them all right? I hope you did. And we'll do some more examples and some proofs in class. Thanks for watching.